Okay, so we want to write f of x, which is given in this form, in this form, right? So basically we want to go from the expanded form of the parabola to the vertex form, right? And the way that we go from this form over here to this one is we complete the square, right? Now, in order to complete the square, there is one requirement that we need to have, right? And that requirement is that the coefficient on your x squared term, right, has to be 1, right? Now you can see that in this case the coefficient on our x squared term is not 1, it's 2, right? So we need to factor this 2 out, right? So when we do that, we'll get f of x is equals to 2, and we'll open a nice big bracket, right? And inside here we'll be left with x squared minus 2x minus 3. Okay, close that bracket, right? Now the coefficient on our x squared term is equals to 1, so we now have permission to continue with the process, or to actually begin the process of completing the square, right? So now the process of completing the square goes like this, right? You look at your x term now, right? Then you're going to take half that coefficient, right? And we're going to put it into a bracket that looks like this, right? This bracket over here is called a binomial squared, right? So we're going to have f of x is equals to 2 into, right? We're going to open a bracket that looks exactly like that. We're going to square it, right? And we still have this minus 3 on the side of here. So I'll leave a space. You'll see now why I left a space over there. Okay, so that's your template, right? So inside over here, we need to add an x term, right? And then we need to add half the coefficient of our x term, right? So the coefficient on our x term is minus 2, right? Half of minus 2 is minus 1, and that goes in here. Okay, so what you put in there is half the coefficient of your x term, right? Now notice something. If we go off to the side over here, if we expand this binomial, right, so we expand x minus 1 squared, okay, we'll have x squared minus 2x plus 1, right? Now we have this foreign, right, plus 1 over here. Okay, we didn't have this initially, because when you compare these two things, right, you have this x squared minus 2x and this x squared minus 2x, and we didn't have a plus 1, right? So this is something new that we've introduced into our equation, right? So now remember, we always need to keep our equation balanced, so we need to compensate in the space that I left here by adding a negative 1, right? So whatever, it's basically, the trick is this that you just put in here, right? So half the coefficient of x, right? When you square that, right, whatever that result is, you put the opposite inside the bracket next to it, right? So we got the result of squaring negative 1 was a positive 1, so we need to add a negative 1. If we got a negative 1 over here, we would put a positive 1 in our bracket over there, right? Okay, so now we are ready to continue simplifying this, right? So when we continue simplifying this, we'll have f of x is equals to 2 into the bracket x minus 1 all squared, right? And minus 1 minus 3 is just minus 4. We'll close that, okay? Then we'll finish this off by distributing this 2 that we factored out back into our bracket. Okay, so then we'll have f of x is equals to 2 times the bracket x minus 1 all squared, right, minus 8. Okay, Now you've successfully applied the process of completing the square on your function of f of x, and that changed it from its standard form. Okay, this is called the standard or expanded form. I'll write here standard form. Okay, so when you apply the process of completing the square on this equation, it helps you to change it into the vertex form. Okay, so why do we want to do that? Well, there's a benefit of the vertex form is to give us the coordinates of our turning point immediately, right? So from the standard form, we see that the y-intercept for this parabola, okay, is at a -6, right? So this is the y-intercept. Okay, it will have coordinate 0, -6. Right, the standard form also just immediately tells us that we have a positive parabola, okay, because this a term is greater than 0, right? So which means that we have a parabola that's facing upwards. Okay, what the vertex form adds to the sketch, right, is that the coordinate over here at the turning point, right, that is a coordinate of 1, right? Remember, you always take opposite of what you see inside of the bracket. So this is 1, and the q value is just the way it is, right? So -8. Okay, right, so that's what the vertex form does. It helps us to add to our sketch that the coordinates at the turning point are the points, right? So if we take it from here, right, it would be the point minus p q, right? If this was written as f of x is equals to a into x minus p all squared plus q, right? People like to stress themselves about this, but this is just general forms, right? And all that you would see in the textbook that when it's written like this, then they say that the coordinate at the turning point is at the point PQ, right? The only thing that they're trying to tell you is that the value of your x-coordinate at the turning point is always the opposite sign to what's inside of this bracket, right? So you see over here, you have a minus p, right? So on the outside, you will have an x value of p, right? Over here in this general form, you have a positive p, so the coordinate at your turning point is going to be a minus p, right? The x value, right? That's all that's trying to say. Don't let these two forms of the general form confuse you. Yeah, it's not necessary to be confused by these two. You can use either or to represent the general form of your parabola. Okay, right, so there we go. You've now successfully completed that question.